Hi everyone and welcome to a new video about current sources using BJTs. This is our example number 5. We continue with the Widlar current source and we will see another example where we calculate the required parameters for this circuit. Of course we will do that in the calculations step by step and also verify these in SPICE simulations. We have the following circuit. In this case we have two DC voltage sources and again the Widlar current source configuration, two resistors, two BJTs. They are matched, so it means they have the same physical dimensions, they have the same current gain, also the early voltage is the exact same. In this case it's infinite. We have given that the VCC and the VE are plus and a minus 6 volts and a VBE1 here is 0.7. R1 and RE is also given and we would like to calculate in this case load current IC2. So before we did in the previous example we need a specific load current and we designed for that the circuit parameters R1 and RE. Now we do it in a different way. So let's see how we can solve this problem. So the solutions, first with calculations. We know the reference current here, I already said, is given by the VCC minus the VEE and minus the voltage across the VBE1 over the resistor R1. Now we can say that is then 6 minus 0.7 minus 6, because this is also minus 6 over 1 or 10 kilo ohms, which is 10 to the power 4, and you will get 1.30 milliamps. Now if we now neglect the base currents, we can write the following. That is what we have discussed in the previous example. This is the approximate analysis or the approximate formula. Now if you want to solve this, you can just substitute the values. You see actually that this is a nonlinear equation. It's not solvable by hand, so you need to use a solver for that. Now this is the graph for this equation. The left side here, which is the ln, is this red curve, which is actually going like this. And the right hand side, which is 5000 times IC2, is this blue line increasing. In this case, the horizontal axis is the load current, and the vertical axis is the value of each of these equation parts, so the left part, also the right part. Now when you look at the intersection point here, you see that the intersection is at 2.0779 times 10 to the power minus 5. That means actually 20.779 microamps. So when you solve this using a graphing calculator or any other plotting program, you will get this solution. So we have actually now calculated our load current. So let's see also that this is indeed correct, because we have found our reference current and also the associated load current for that. Now let's see, this is the simulation. We see the 10 kilo ohms and 5 kilo ohms and also the voltage sources DC and also our BJTs. You see here the 20.358 microamps, which is a little bit smaller than what we have calculated. Now IRF is very close to what we have. It is actually 0.005 milliamps larger, so 5 microamps larger. We see in our simulation results that the values are very close to what we have calculated, so we can safely say for all practical purposes this is perfectly fine. Alright guys, this is our example number 5 where we discussed the Widlar current source using the BJTs. If you have any questions, comments about this example, please let me know in the comment section. I will try to answer them as soon as possible. See you next time in another video. Take care.